Hey you guys, I just want to do a very quick video on making predictions using experimental probability. This is 7.6c. What I've seen in class is that I think that there's probably a need for us to do a little bit more practice and see a little bit or more examples. So I just want to go ahead and bring that to you now. The first example that we're going to talk about would be at a candy factory. Okay, we know or you may or may not know, but when food is being manufactured, sometimes there are defects, and at times they have to throw out certain things because they just don't meet the quality standards of that company. What if we had the Snickers factory? Okay, I'm going to change colors here. The Snickers factory. We knew, or they know, based upon previous production runs, that about 2% of Snickers bars are not up to quality standards, okay? And on their next run of 10,000 bars, how many the number of bars that will be thrown out, okay, or discarded. Let's write right out of space, okay. So we want to know how many are going to be thrown out. So 10,000 bars. How can we predict the number of bars that will be thrown out? And again, based upon their previous information, they know that about 2% of the Snickers bars are not up to quality standards, okay? And I have left out a word here, okay? They are not up to quality standards. So let's go ahead and figure out what that would look like. So I am going to go ahead and figure this out. So I know, first of all, when I am making a prediction, I need a probability, and I need a certain number of trials, okay? So, probability, and then the number of trials. So what I'm going to do is I'm going to set this up as we have in class. I'm going to set this up as the probability of 2%. I'm going to set that up as a ratio. We know how to do that and convert between 2% and a ratio. So for every 100 bars that are made, about 2 of those bars are not going to be up to quality standards at the Snickers factory. I'm then going to multiply that by the number of bars, or aka the number of trials that I'm going to complete. So the next 10,000 bars that are actually made, I'm going to set that up. Okay, that's 10,000 and put that over 1, because remember, any number over 1 is going to be a ratio. Okay, any number over 1 will be a ratio. When I do that, what I can do is I can multiply that out. 2 times 10,000 becomes 20,000. Multiply 1 times 100, that is 100. Okay, I know that I could also simplify by crossing through certain zeros. So the number of zeros that are left are 2. That's 200 over 1. I hope you see that. Or just 200. So how many bars can we predict that they will throw out based upon not meeting their quality standards? About 200 bars do not meet quality standards. Okay, so on to my next example. We estimate that about 35% of middle school students play video games at well, let's say during the week. Okay, erase that, write that over. Okay, so again, they play video games during the week. Okay, so if we, for instance, went to a mall, okay, we know that based on experimental probability. That means that about 35% of middle schoolers play video games at some point during the week. If we set up at a mall and at the door, okay? So if we were at a mall, so there was a mall polling of 500 students. So how many of those students could we predict based upon this experimental probability? And where that experimental probability came from, we don't know. Maybe they just did a national poll and they estimated that about 35% of middle schoolers are playing video games each week. Okay, and of 500 students that were at the mall, how many could we predict would actually be video game players? So again, I'm going to set up my probability as 35 over 100. That is the equivalent of, I'll turn that down so we can see a little bit better. 35 over 100 is estimated to be the equivalent of 35%. It is the equivalent of 35%. I'm going to multiply that by the 500 kids that are polled at the mall. We know that I can cross simplify, so the greatest common factor between 100 and 500 is going to be 100. 100 divided by 100 is 1. 500 divided by 100 is going to be 5. Okay, and then I'm going to multiply that out. When I multiply that out, that becomes 175. So my solution statement would be that 175 students at the mall are assumed / predicted to play video games. Okay. Now, my last example, we're going to do something slightly different. We're going to set this up as a proportion. If setting it up as a proportion makes more sense to you, then that's exactly what we will do. Okay? So, uniforms at school. We estimate, or say Alvin ISD estimated, that about 40% of students, and this is a made-up stat, okay, I don't know this to be true, this is just made up for this example, 40% of students will wear an Alvin ISD Spirit shirt, okay, of some sort to school, okay, whether it be the choir, the band, art club, something. So they'll estimate it that about 40% of students will wear an Alvin ISD Spirit shirt, okay? So what if I wanted to set this up as a proportion? Maybe that makes more sense to me. First thing we need with a proportion, we are still going to use the probability. We're still going to use the number of trials. So what if we had 1,000 students that were at a game or something, and they came straight from school and they had on whatever clothes they wore? So 1,000 students were observed at a district function, okay? And we just figured out what kind of clothes they had on. Did they have on a Spirit shirt? So how many can we predict would, out of this 1,000, be wearing an Alvin ISD Spirit shirt? Let's set this up as 40 over 100. So for every 40 students, for every 100 students, 40 of those would be assumed to be wearing an Alvin ISD Spirit shirt. Let's set that as equal to some number, X value, over the 1,000 that we observed. So again, this is part over whole. What part of these 1,000 are expected to be wearing this? Excuse me. So I'm going to figure this out by using that proportion. As I said, what's happening? What is the relationship between 100 and 1,000? We know that in a proportion, I can figure out that relationship. That is being multiplied by 10, okay? Whatever I do to the bottom, I must also do to the top, so I'm going to do that. I'm going to multiply this by 10, so my X value is going to be 400. So my solution statement is 400 students at a district event. Let's erase that, sorry. At a district event are predicted to wear a Spirit shirts. Okay. Now, I hope that this has helped you tremendously. Okay. One thing that I want to say also is that if you do not get this, please back up the video and watch it again. If this still did not make sense, please come to one of my tutorials on either Tuesday or Thursday here at school. Okay. And as always, if there is anything that I can answer in class, I'm happy to do so. And I will see you tomorrow.